Yeah, so just a bit of intro. I mean, I suppose we'll kind of covered it, but I'm an SRE at Google. I've been there for about 2 years, and I work on Google's highly distributed, high QPS, key value store. And so it lets me learn lots of interesting things and solve interesting problems. But yeah, today in this talk, we're going to be talking about shrinking production incidents, or a data-based approach to setting engineering priorities based on your outages. So we're going to look at what a service outage is and what it means to you, how you can learn from them, and how what you learn you can use that to set your engineering priorities. So later on, we'll discuss specific engineering tasks that you can use to target your reliability weaknesses. So just give you a bit of a background about what SRE is. All this will be framed in the context of SRE. So SRE is very close to DevOps, and they kind of started forming roughly at the same time, but SRE has a bit of a different spin on how to implement DevOps. So SRE started because Google leadership discovered that traditional operations doesn't scale well with the way the service was scaling. So really what you want is, as your service grows, you want your operators to grow sublinear to the service. So you don't want it to be one-to-one. And then notice that wasn't happening. So SRE is the result of turning operations into a scalability problem based on software. So basically, you're turning operations into an engineering philosophy. So it's a mindset, a dedicated job, and a set of engineering best practices to solve the scalability problem. And at a high level, this is probably where DevOps and SRE differs a bit, is that SRE really focuses on aligning incentives across management, development, and operations. So it looks at business, software development, and the operations sides, and sort of says, well, how can we fuse them together? So really what it's trying to do is promote development velocity while enforcing reliability. So based on how reliable a service is, we can basically allow our developers to go faster or pull them back if things get unstable. So some fundamental concepts related to SRE. Error budgets, which I'll discuss a bit later on, but basically it's a way of measuring the amount of risk you want to take on in your service. SLOs, or service level objectives. It's basically a measure of how reliable you want your system to be, and it's a measurement of something like a longer dimension that your users care about, so it's important to them and represents some form of happiness to the user. And Blamelessness, Postmortem, so basically a way to review your outages in a way that you can extract the most value. So I'm going to not go into all these very deeply, so there is a bunch of information on google.com/SRE. Go ahead and read it. There's lots of free material. It's very worth reading. So I think this is pretty apparent to everyone, but happy users stay and unhappy users leave. We all work in a competitive environment, and if your users get unhappy, they're going to take their business elsewhere. And this isn't necessarily a living relationship either. So one unhappy customer has greater impact than a single user. There might be several people who hear your service is bad and now they won't come to your service. So one thing we typically do when we build something is we think about it in the features that we advertise. So generally you define, what you care about in terms of your use case and value proposition. So what features enable those things. So it's always directly related to your product. But today I'm going to talk about probably the most important feature that your product can have, which is reliability, because without reliability, no one's going to be there to use your service, right? Because it's just too unstable. So it's better to have a reliable service that only has a few features than have something that's got all the bells and whistles but is never stable. So when we talk about reliability, we're talking about service disruptions or outages. The systems we build are generally complex and large, and they're constantly changing. So it's not a question of if an outage will happen. It's more or less when it will happen and how bad is it going to be. So we should look at how your stability of the service changes as it over time, and how your user happiness relates to instability. So basically, you're going to have some form of peak happiness, and that's when your service is most stable. And as things go wrong, you're going to go down the graph, and you're going to have unhappy customers. So to talk about this, we're going to talk about certain phases of this stability cycle. So just going through it, you've got peak happiness, an outage begins at some point, and then your monitoring is going to say something's going wrong. an alert will fire, and then your responders will start to be able to look into the issue. And that's the time to detect. So your on-calls are now working on the issue, but obviously as they're still working on it, your users are still getting unhappy. And so as they start to mitigate the problem, it's going to start to turn around. And that is your time to mitigate. And so as soon as you've mitigated the problem, your happiness increases again. And that's going to happen for a duration until the next outage occurs. And so that's the time between failures. So one thing you have to think about at this point is, well, how much did this just cost you? There's the obvious things like you've just lost revenue. If you're a commerce site, you can sell items. There's also the reputation cost. So you've just lost potentially a few frustrated clients who never come back. And so their friends and colleagues won't use your service either because your reputation's gone. And also you might make the press. So if you're big enough, you might hit front page Twitter or some news feed of some sort where you get a lot of negative press. So one thing you can think of at this point is, if you had to pay to prevent this outage, how much value would you invest into it? And so that's where postmortems come along. It's kind of a way of turning the problem around. So you've already paid for the outage, and now you're looking at to extract the value for your accidental investment. So how can you invest in your tech stack to basically make future outages less costly and less likely to fail? So this is why we use postmortems. You use postmortems to make sure your incident is documented so that you have a historical view of things that go wrong in your system, and that it's kind of an archive so people can refer to them in the future. It allows you to explore the contributing factors and root causes and make sure they're well understood. So when a system fails, it's typically not one single failure point, it's multiple systems failing at the same time in a similar way, which brings down your system. So having this document, you can look at those causes. And based on what you learn there, you can look at the effective actions you should take to mitigate them in the future. And so when you're doing this, you're not looking at just this one particular instance, you're looking at the whole class of problems that you found by exploring the problem. And so you can reduce the impact and your recurrence likelihood of it happening in the future. So really you write a postmortem after any significant undesirable event, and that doesn't necessarily need to be your clients or your customers have seen it. It can be that you had a near miss and you picked it up in your monitoring before anyone else was aware. So writing a postmortem is not a punishment. It's a way of extracting value from your outage. It's an engineering process to basically go, what went wrong and how do we fix it? So often in engineering, we'll look at things and we'll say, we'll build something because we think it's a good idea. We want this feature because we think it serves our customers. But with an outage, basically you've got the costing for reliability. So reliability is very hard to cost up front, but once you've had this outage, you can kind of say, well, it just cost us this amount. So, we can invest this amount of money to stop this happening again in the future. So when we talk about postmortems, we want them to be blameless. And it's the fundamental feature of a postmortem. And for an example, say you had an on-caller that was attending an outage and they reacted by manually restarting a bunch of servers because they noticed they were running out of memory. And this restart caused a cascading failure, which caused the remaining servers to kind of go unhealthy, and then basically your whole service came down in a way that was quite impacted. So you stop and ask, well, why did the engineer restart this many servers at once? And perhaps it was standard practice. So the postmortem might point out that in the past, this was the thing that we did. It was the normal thing to do to restart servers in memory issues. But clearly the information the on-caller had at the time was wrong, so the wrong decision was made. So this is why you have postmortems. In the postmortem, you could identify potentially that there should be tooling that's made available to make sure your on-caller can't restart too many servers at once, so you don't lose so much capacity. It also gives some evidence to development to say, well, look, we're getting all these memory leaks in production, so you need to go fix them because it's causing outages. So the thing about blameless postmortems is that you're assuming everyone's working with good intentions and in good faith, with the best ability with the information they have. So that means really you want to make sure you do these postmortems without identifying people. So you're trying to identify the causes, but not implicate people. So when you refer to people in the document, you don't refer to them by their first name or anything. You just say the on-call engineer. sort of did this task and then this caused this problem, and it was related to code commit 123 that caused this memory leak problem. So really what you're trying to do is get the information about what caused the issue, but not point the finger at anyone, because then you're removing the intent of the postmortem, which is to find the engineering cause. So really what you're doing is fixing systems, not people. It's not the people's fault that your system failed, it's that the system allowed them to do something that was dangerous. So it's important to be aware that when we say you're not looking at people, you can still look at the fact that you need to train people, but you're not pinning the blame on one single person. You're sort of saying, you know, our process doesn't make sense, or there's some information that's missing, so we need to look into that. So the reason why we do this as well is that blamelessness motivates a culture of, you know, employees being able to raise up their hand and say, look, I'm seeing these problems, and they can identify issues. And that's because they won't have the fear of being blamed, and also possibly the fear of getting someone else in trouble. So having this blameless culture allows people to sort of freely talk about the issues they're seeing and allow you to go fix the service. So where should you focus your efforts? Once you've had a few outages, you'll get enough kind of critical mass in your postmortems to see patterns that are emerging, and that will give you an idea of where to focus your engineering effort. So really what you're going to do is focus on these 3 phases that occur. So your time to detect is going to be based on your monitoring. So you're looking at your metrics and your alerting. Time to mitigate's more of a people problem. So it's, you know, your training and your runbooks, making sure your responders don't panic and they have the information available to them that they need. And then your time between failures is about dev practices and your continuous integration and deployment, and sound engineering designs as well. So we're going to zoom in a bit on how we should tackle these problems, but I just want to recap on some terminology that maybe people aren't totally aware of. So when I say SLI, I'm saying service level indicator, and that's a measure of system performance in some dimension that you care about and matters to the user. So for example, it might be latency or successful requests, and it's an indirect proxy to user happiness. SLOs, or service level objectives, are how much user unhappiness you're willing to tolerate as a business. Really what you're saying with this is you have a percentage and a threshold. So you might say 99% of requests need to be served under 20 milliseconds, otherwise our users get unhappy. And you know, things like the service will be available 99.9% of the time over 30 days. And so whatever's left over from that percentile, so for 99% it will be 1%, that's your error budget. And it represents how much risk you can take on, basically. If you burn it all too quickly, it means you need to pull back and make things more stable, because, you know, your service is basically showing too much instability. But if you're burning it quite slowly, it means that you can increase your velocity, so your developers can release features quicker. So you can kind of think of the error budget and how much you're burning it as an accelerator to your developer velocity, and it kind of indicates on the amount of risk you're willing to take. So shrinking time to detect. Basically, once the outage begins and the period between you sort of the outage occurring, you detect it, that's when you're going to get the peak burn in your error budget. So if you don't attend to the problems quickly, you're going to run out of error budget, and so you won't have any developer velocity left for your sort of time cycle. So basically, the time between the outage occurring and your on-callers being aware of it is very important. So you want to get that as narrow as possible. So if you're in your postmortems, you keep seeing that you're burning too much error budget during this period, it basically means you need to tighten up your monitoring metrics to make sure you're measuring the right things. So shrinking time to detect, there's a few things you can look at. You can look at refining your SLIs. So when you define an SLI, you want to get a good representation of user experience. So one way of doing this is measuring as close to the user as possible. So you're kind of trying to say, what's the best proxy I can get for their experience? So if you could measure at the client, we'd be literally measuring the latency they're experiencing or the number of successful requests they get. And the reason why you want to do it end-to-end as close as possible is that it allows you to gauge the user experience in its total. So if you're going across flaky links and you say my user experience should be 500 milliseconds, but you consume 400 milliseconds of that just getting across the network, then you know you've only got about 100 milliseconds to play with in your service to give the user the experience you want to give them. So even though you can't directly control things like external networks to you, it does allow you to tune your system to what they're experiencing, so you can do something about it. And one thing to be aware of is, I suppose, the less close you are to your user, the more of a headroom or fudge factor you should have in your metrics to say, well, we know we don't totally measure client experience, so we need to have a bit of headroom to make sure we have that buffer. And the other thing you can do is verify against external sources to see if your SLIs make sense. So say your monitoring is going off and saying that you're seeing a problem, but no one seems to care, then maybe your SLIs are measuring the wrong thing, right? You're looking at the wrong dimension. Or it could be that everyone's getting really grumpy and your metrics tell you that it's totally fine. So again, you're measuring the wrong thing. So you can look at external sources. It could be that you look at Twitter and see if anyone's getting grumpy at you and saying your service is bad. Or you can reach out to your customers directly and say, how are you finding the service? So the other thing you want to do is refine your SLOs. So your SLOs are based on your SLIs, but you need to look at thresholds and the percentiles you need to use. So you need to iterate them a lot to make sure they match what your user experience needs to be. When you define an SLO to begin with, you're kind of making an approximate estimate kind of thing of what you think your user experience should be, but you'll find out as you use your service more that maybe you got that wrong. Sometimes it can be that you set something that was too strict and you actually, you're taking on cost by having something that users don't care about. Other times it might be that your users care about a dimension more than you thought they did. So for example, for availability, just say you said initially, I think my service needs to be available 99.99% of the time. And it turns out your customers say they only want it available 99.9% of the time. Then you've got that factor of 10 engineering cost, basically from an operational point of view, keeping your service running at this higher percentile. So by looking at your SLOs, you can adjust your costing about how much it costs to run your service. And that's the same for latency as well. So if you find out that people don't care about latency as much as you expect, then you can push up the utilization on your servers and sort of drop off the number of servers that you have up at any one point. So that comes to the next thing, so creating effective alerts. So you've got a good SLI now, you've looked at your SLOs and you think it's measuring the right thing. So you need to write alerts that are user-focused, right? So it's on the dimensions that your users care about. And basically they should be sensitive enough and actionable as well. So it's a balancing act with what that means. So basically you want things to be able to detect a problem early enough that you don't burn your error budget and make your users unhappy, but you want it actionable as well. So if you have something that's too jumpy, then basically whenever the pager goes off, someone's going to go to look at the page and realize, oh, hang on, it's resolved itself. So you've gotten someone out of bed at 12 o'clock in the morning to go fix something that doesn't actually matter. So you've got to balance, you've got to find the right balance between what matters and what doesn't. But if you focus on these things, you should be able to get the time to detect down to a reasonable level. So shrinking your time to repair. The time to detect was a technical task, but time to repair is about people, policies, and training. So one thing you'll need to do is look at how do you make sure that your on-callers aren't in a panic state when they get an alert. So this is a really important thing to get right because you're always going to have outages. You can't automate all solutions to be quick. There's always going to be something that slips through the crack. You can't engineer everything out. So your people are the last line of defense and they're one of the most important. So you need to make sure you invest money in training them properly. So a quick reminder is that during a mitigation event, your on-call is not fixing the root cause. They're just trying to get the problem mitigated and get the service back up and running. So they're basically fighting fires essentially. So a good response during this event would be, you provision more capacity, you do a version rollback, you do temporary failovers, redirect resources. A bad response would be the on-caller digs into some code of some release, makes a patch, does a release, and tries to get into production. That's going to take a long time. And the other thing with that is that you're in a risky area because now you're trying to change a change and there's no way of knowing whether that's going to make the problem worse, right? So you always want to take the path that seems the safest, which would be just looking at the simple things you can do. So basically, you should look at the more complicated problem of solving the root cause when your service isn't burning any longer. So shrinking time to mitigate, you want to train the responders. So you need to have an emergency procedure that's well documented and has, the items that you care about, and it's the on-callers know how to respond to the alert. But you don't want so prescriptive either that they can't do ad hoc investigations. So they need to be able to explore the problems, because it's not necessarily true that the emergency they're seeing is exactly the same as other situations. And you should train more than just your on-callers in these processes. So you can train your developers and your project managers and product managers, so they get an idea of how your service needs to be managed, and then they can look at stability around that as well. So one thing that you can do as well around this is run weekly failure drills. So at Google, we run a failure drill every week. Some of it's on a live system, on a replica that's not serving, user traffic. But you basically inject problems into it in a way that allows you to practically exercise their skill sets. And it doesn't necessarily need to be complex. It can be just solving through a simple problem, like someone can't log into some system, or something's gone offline. But basically, during this exercise, you can go through your playbooks or your emergency notes and say, can we follow them and actually get where we want to be? So to do that, you need to write a suite of runbooks or playbooks. And your playbook should have full alert coverage. So any alert that gets triggered, your on-caller should be able to get some information about what it means and have a basic idea of what they're looking at. So your alert should have clues for investigation, right? So it should have quick links to dashboards that are important for debugging the alert. Any search queries that might be useful in your logs to say, you might see this when this is occurring, or possibly people to escalate to. So if you get this problem, send an alert to this other person. So it's basically anything that they may need to know to help them solve the problem. And you're not going to be able to know everything, and you're not going to be able to document everything. But at least by having some of these points down, they're going to have a feeling of when to escalate onto a different service potentially, because they realize that it's no longer their problem, it's something else that's going wrong. And you need to write your documentation for a newbie. So it's quite often that people write a playbook in something they understand, and then someone else during an emergency comes to read it and says, I don't understand what this means. There's all this information missing. People have made assumptions in what's going on. So a good way of doing this is basically writing a playbook, and then through potentially one of your weekly drills, you run through the playbook as an exercise and say, does it make sense? Do we need to update anything or have further clarifications? But basically you should write a playbook so that if you came back in 6 months' time or a year's time, it would still make sense to you. And you should verify it often. Things change in production, so some assumptions you made about the services you're relying on can change. So people's skills get rusty as well, so you should always go through your playbooks and make sure that they're up to date and have relevant information. The next thing you should do is manage responder fatigue. So you want to manage with page load. We found at Google that anything more than 2 pages per shift starts to put too much stress onto your on-callers, and so they become less effective at attending to the service. And so if you're finding that this isn't, the next thing is eliminate toil. So one way to reduce load is make sure that you automate anything away that's kind of something that you always would run. So if there's a bunch of commands that you should just run, instead of having them manually type it out, you'd actually automate it. And that reduces the likelihood of errors as well, because you've got this set, tooling that will do things for you. And you should shed the load as well. So if your pager count is getting up too high, then basically bring development in and let them experience what it's like to hold the pager for a day. It's pretty motivating that, when a developer sees that their service is quite unstable, that they should go fix it, because it's actually quite stressful when you're getting a lot of pages. So it's a good motivating factor. The next thing is dashboard and logging. So you want as much relevant info at your fingertips. Basically, our motto in SRE is to just monitor everything. We look at thread queuing, we look at memory contention, we look at basically anything and everything. And the reason for that is sometimes when you're exploring something, it ends up going down quite deep into the serving stack. So you need to be able to find out where the root cause is. But because you're collecting this amount of information, one thing you have to be aware of is retaining all of that can be quite expensive. So after a period of time, you look at basically dropping some things off that don't make sense, and you just keep the important information that you need to have hanging around. And that's just to manage cost. So the next thing is expanding time between failures. So, you've had an outage and it's mitigated and everyone's happy. So, what's the one way to make this stop happening again? Well, we found at Google that basically the common trigger for an outage is basically someone's release a new code or change some configuration. So the obvious thing to do is just freeze everything. Don't do any more releases. And that does work for certain situations. It might be critical days of maybe some weekend where you need to make sure your service is extra stable, say like a Cyber Monday or something like that, where you need your service up. But in general, there's always going to be features that need to be released, bugs to be fixed, hardware to support new threats that you found. So really what you want to do is make your changes safer, not stop them altogether. The other thing as well is when you go too long without an outage, your on-callers get rusty. So when that outage does come, they don't have that kind of critical thinking anymore because they're not used to servicing things under pressure. And if you stop releasing things, then obviously it has an impact on your business because your developers can't release features. So you've got market forces that are going to have to push you into releasing features. So in general, to solve the problem, you're better off looking at trying to fix your time to detect and time to mitigate than looking at trying to expand your time between failures. So how do you maximize this time? It comes down to dev practices. So you need to foster a culture of quality. You should always have major design changes should be reviewed and documented. Your code should have style guides. You spend more time reading code than actually writing it. You should do code reviews and they should be small. So code reviews should be kept to a minimum of 200 to 400 lines because they start to lose effectiveness more than that. And if you keep them small, it's actually easier to revert code and spot identify where the root cause of the problem might be as well, which is important for rollbacks. And you want test coverage. So basically you should have unit tests, integration tests, end-to-end testing as much as you can, and it should cover all the edge cases you're aware of. The other thing is testing actually is kind of self-documenting for your interfaces. And if you keep your testing simple, people can understand how your classes and things are meant to work. So the next thing you want to look at is continuous integration and continuous deployment. And with this idea that you've got small code commits, you're releasing to production often, it basically means that if something does go wrong, you've got a pretty good idea of where the problems occurred. You don't have to go digging through, 3 or 4 months worth of code to go, well, where's the issue? So one thing you should do when you're checking in code is do automated testing. Everything that we push in Google is basically unit tested, end-to-end tested, integrated tested. So you can tell quite quickly if something's failed. And that leads you to doing gradual rollouts as well. So you've done these small changes, you've got this full CI process, but you don't want to just release it onto the world in one big hit because you might have this hidden problem you're not aware of. So what we do is we do canarying, which is basically we select a small population of servers and we say maybe 1%, and we test on those. And as we get more confident that the release is stable, we grow that size of percentage, right? So eventually you end up taking on the whole fleet. But if you detect a problem, you should have automatic rollbacks. So you don't want to have to babysit a rollback. You should be able to push a button and have automation bring the release back for you. So this means it's important to have your releases being version compatible between each release, because there's quite often you're going to have at least 2 versions in production at any one time. So you don't want to run the risk of, not being able to you don't want to have a break and change that if you come back, your service is no longer going to work. So you need to build robust architectures as well. So no single points of failure. You should have redundancy. So it might be that you have alternative paths or multiple copies of the same service, and you use some kind of master election to decide what's going to run. And you should have graceful degradation. So instead of totally dropping your service off, you should look at how you can bring the service back if you're starting to experience instability. So it might be that you serve your customers a less of the experience, but you're still serving them something so they don't get the full outage. And that's important to make sure your customers stay happy. And then you can use something called chaos engineering, which is basically meaning that at scale, you inject faults into your system to see where it breaks. So you should look at your system and look at where the possible failure points are. and sort of go, well, let's poke them and see how we can break them. Because what you're trying to do is find issues before they find you. So by doing it in a controlled manner, you can kind of make sure you minimize the impact. And with that, you should do automated disaster recovery. So what can happen is you get dependencies forming between your internal services. So if you have a super stable internal service, everyone starts to rely on it being stable, right? So what you should do is occasionally bring that service down. So that way, you know that your users, like your internal users, don't depend on your service being up all the time, so they can make their system more resilient and reliable. So really, the moral of the story is you should let the postmortem guide you. If you invest in your failures, basically it will lead you to success. So look at what the postmortems are telling you and let that drive your engineering process. And that's it.
Fantastic. Thank you